In this lesson, we're going to look at the gradient of a straight line. Other names for this are slope or steepness. We have a fair idea of steepness in our everyday life. For example, if we had flat and level ground, we'd probably say that's not steep at all. In fact, it has no steepness. We might say it has zero steepness. We could be walking along a slope like this uphill, and we might say that's a gentle steepness. So the steepness is not a very big number, or we could be going downhill. Here is quite a steep incline. We're going up a quite steep incline. It's much steeper than this first one. And here we have a vertical cliff. We might say that's extreme steepness. The question is, how do we define steepness? So this one we can say has a steepness of 0 because it's flat and level. What about this one? Well, the way we've decided to define steepness is we take 2 points on our incline, say here and here, and we're going to draw ourselves a right angle triangle with a flat horizontal side and a vertical side, a little right angle in there. And we can put a number to steepness by comparing this vertical distance over the horizontal distance. And we can see that the vertical distance is not very much compared to the horizontal distance. So one way we can define steepness is vertical distance divided by horizontal distance, and that will give us a size or a number for the steepness. We do the same thing here, make our 2 points anywhere on our line, and we can draw our right angle triangle with a horizontal side and a vertical side. There's our right angle. And we can see this time the vertical distance is much closer to the horizontal distance. In fact, it's about 1. And it turns out if that's 45 degrees and these are the same distance, it is 1. So a steepness of 1 is very steep. What about this vertical line? Well, we put our 2 points on again, and here we can't draw a right angle triangle. We can get the vertical distance in, but we have no horizontal distance. So if we have a number for our vertical distance and we have no horizontal distance, it turns out that our gradient or our slope here or our steepness is undefined because we can't divide by 0 in our number system. So we can see that a horizontal line has a steepness of 0. A vertical line has a steepness which is undefined. And we should be able to tell steepness in order of magnitude by looking at the lines. The question is, how do mathematicians describe this? And it turns out they do it pretty much the same way. So mathematicians use a more precise straight line, pick 2 points, and write a right angle triangle in between them, and the magnitude of the gradient or the slope is the vertical distance divided by the horizontal distance. And so mathematicians draw their straight lines on the Cartesian plane, which we've seen before. Here's some examples of straight lines. Now, there's a problem that mathematicians have to deal with. Are we going uphill or downhill? So they have to be able to distinguish between lines that are going up to the right or down to the right. And so they got together and decided on this convention, that if you head in the positive x direction and imagine yourself walking along the line, if you're going uphill, up to the right, it's a positive gradient. And if you're going downhill, down to the right, then we have negative gradients. Now there are formulas for deciding the gradient between 2 given points, but that's not the best way to work out gradient. We'll just combine these 2 ideas. First, decide whether your gradient is positive or negative. Second, select 2 points that you can clearly see the coordinates for, and draw your right angle triangle and calculate the vertical distance divided by the horizontal distance. If the gradient is 0 or undefined, we don't need to draw ourselves a right angle triangle. We can decide that first straight away. So once again, first decide the sign, positive or negative, calculate the magnitude of the gradient by drawing your right angle triangle. Let's have a look at some examples. Here we have to work out the slope of a straight line between the 2 points 1, 4 and 4, 8. The best way to do this is to make yourself a sketch. Helps you get a sense of the problem. So we sketch our x and y axes in, and we roughly locate the point x equals 1, y equals 4, about there let's say, and 4, 8, so about here. So let's label them with their coordinates. That's 4, 8, and this is 1, 4. And there's our straight line. Make those points a bit bigger. The next thing we want to do is draw our gradient triangle in between the two given points, about there. There's our little right angle triangle. Firstly, we can see that the gradient is positive because it's going up to the right. Now, in your work, the symbol that mathematicians use for gradient is B. If you're like me and you've done maths in year 9 and 10, you might remember the symbol they used for gradient was M. They're really the same thing and it doesn't matter. So we'll use B just because your textbook does. Okay, what's this vertical distance? Well, the vertical distance is the y values, and the y values are the second value in the coordinate pair. So that's 8 minus 4, which is equal to 4. The horizontal distance is the x values. This x value is the first value in the ordered pair, 4, and here it's 1. So 4 minus 1 equals 3. So the vertical distance over the horizontal distance is 4 over 3, and this gradient was positive, so I don't need to put the plus sign in. In this next example, we want to find the slope between 2 points 0, 10 and 4, 2. So again, we'll sketch it. So we sketch the axes in, and we'll locate the point 0, 10, which is up here, and 4, 2, which is about here. And we'll label them with our coordinates. Now, we'll just draw the straight line in, and we can see that the gradient is negative because we're going down to the right, so we put that in our answer straight away. Now, there's a number of ways I can draw my right angle triangle here. I could draw it this way, or another way across here and down there. Doesn't really matter, it's just a right angle triangle between my 2 points. Let's look at this vertical distance here. We'll work this vertical distance out. It is the y values, the second values inside the brackets, and that's 10 and 2. So the vertical distance is 10 minus 2, which is 8 units. Now the horizontal distance here is the first value, the x values, and that's 4 minus 0, which is just 4. So our gradient is equal to 8 over 4 as far as the size of it goes. We've already decided it was negative. Now, whenever we get a fraction for gradient, it's best to leave them as fractions. They should be simplified fractions, simplified improper fractions, in fact. Okay, so this comes out to negative, and 4 goes into 8 twice. Here's our last example, and again, we've got our diagram already given to us, but we can draw in our diagram here. We're going to put our right angle triangle in. So there's the right angle triangle we want. Vertical distance here over horizontal distance. So firstly, you can see that our gradient is positive. So I don't need anything in front of my fraction. And the distance between the y values will be our vertical distance. That's 17 and 3. So the distance between 17 and 3 is 14. So that's going to be our top number. And our bottom number in our fraction will be the horizontal distance. Now we don't care about signs. We've already decided our sign was positive. We're interested in distance. This is an x value of minus 2. So this distance here is 2 units. And this distance over here, well, this value is 5, so that's 5 units. So if we've got 2 and 5, that gives us a total distance of 7. So that's how we work out that one. So 14 divided by 7 simplifies to 2, and that's our gradient. Now, a bit later on, we're going to be sketching gradients. We're going to be given the gradient, and we're going to be given a point, and we've got to draw our gradient triangle to find a second point. When that happens, when we're given the gradient as a whole number, one of the things we do to help us draw our little right angle triangle is to put that whole number over 1. And that will help us go across 1 and up 2. In fact, the interesting thing about straight lines is that what makes a straight line is no matter what 2 points you choose, the gradient stays fixed. So for this straight line, for every one you go across, you go up 2. Go across 1, up 2. So if I use that idea, I can figure out the y-intercept here in this question. If I go across 1 and up 2, I'll be at 3 at a y value of 3 plus 2 or 5. Then I go across 1 and up 2 again, I'll be at a y value of 7. And that will be in some later lessons. We'll look at those details.